Hi everyone, welcome to Perspective Projection for DCG. So you might be familiar with one point perspective. Okay, so for example you can see here a train track and I have a horizontal plane and a picture plane and I have the ground line, and here's Quagmire, okay, and Family Guy, and the horizon line here is basically the end point of our field of vision. Okay, and what Quagmire is going to see in this situation is his version of the train track, and as you can see, as the tracks appear to him, they appear to narrow and disappear as they approach the horizon line. With 2-point perspective, we're going to take an L-shaped object. Again, we have a picture plane, a ground line, a horizontal plane, we have an object, we have the spectator, again Quagmire, and we have a point of that object on the actual ground line. So you can see that the field of vision now, okay, is going to be shaped by the position of the spectator. All the points in the object are transferred back to the eyes, and you can see how it now begins to appear on the actual picture plane. And what is contained on the picture plane is what we actually see in real life. So there's a slightly distorted looking view of the object as it appears to the spectator. And again, colours and surfaces are highlighted. Here's that L block now in terms of the actual set out for a question to be drawn on paper. We draw the plan view, we locate the spectator, we find the picture plane, we locate our vanishing lines, we extend them out. This is the orthodox way. Normally we do it in reverse, but for orthodox for this example, we have our horizon line. We have lots of information that's given to us that allows us to construct all of this, and I will go through that on paper in the paper example in a few moments. However, you can see how certain features are now beginning to appear, okay, and that we're actually going to be able to generate now our perspective view based on the positioning of the spectator in relation to the object, and that's all based on working from a plan view and a position of a spectator. So it's a really nice topic, alright, and you get some really nice presentable solutions. So we have the plan view of the L block, alright. We have the spectator is located at 45 degrees from corner A at a distance of 80 millimeters. So here's the spectator, okay, right there. That's the point, there's the line, and here's the plan view, okay, as I've just talked about. Now, what I want to do in this situation, guys, is I want to join a line back from the far corner here back to spectator S, like so, like that, okay, and from the far corner of the object here back to the spectator S. Now I have these two lines, okay. What I am going to do here, and these are all steps that we'll take when we do this, you know, in every question. I'm now going to take my compass, I'm just using my one with the colour in it, put the point of the compass on S, and we're going to bisect the angle created by those two lines. So the angle contained between the two lines that I just drew. So to bisect the angle, we know how to bisect an angle, so I'm not going to go through that. Okay. And there's the point of intersection, and what I'm going to do is from S now I'm going to draw out through that. I'm going to draw the bisector, and it'll be a green line for you at home, okay, like so, okay, and I'll write bisector there. That's a very important line, because that picture plane I was talking about earlier is going to be at a right angle to the bisector line, okay. So in this case, what I do is I line up the inside of my set square with the bisector line, and I line up the other edge of it with the point A, because I want the picture plane to pass through point A. So this is the way I would, this is a shortcut to doing it, otherwise you'd be using a protractor and there's a couple of moves in it. So I line up the inside line here with the bisector line, that's the green line, and then I line up my other edge with point A. Okay, so what I'm going to do there now is I am going to draw just a small portion of a line, and that represents my picture plane. Now I need to extend it on in both directions. So what I'm going to do, now that I have the line there, draw it on that way, and then draw it on this way. Okay? And that is your picture plane. Now you're going, well, it doesn't look like the plane that was in the previous animated version. No, it doesn't. This is the plan view of it. Okay? Picture plane here. Okay, and normally that's just denoted as the PP line. And it appears as a line here because this is a plan view. Okay? And here's the spectator, and as he sees this object, it's going to appear on this picture plane, and we're drawing the elevation of the picture plane somewhere up here in a few moments. Okay? Now, what I need to do is I need to draw my vanishing lines. So, to draw the vanishing lines, what I do is from the spectator, S, I'm going to draw a line that is parallel to this side of the object. So you can see that this line is parallel to this line, and we extend it until it meets the actual picture plane. Then on the bottom here, I'm going to again from the spectator draw a line across to meet the picture plane, and I have it there. Okay, so now I have a line here which is parallel to this side of the object. Okay, so what I want to do now is I want to project out at a right angle off the picture plane. So whatever angle this picture plane is, we're going to project out at a right angle off it. Okay, again, you can use your set square here if you want. Just line up the inside line here with the picture plane, and line up your outside line with the point on the actual, I'll just hide that, with the point located on the picture plane from the vanishing line coming across. Okay, so I'm going to line it up there, and then I'm going to draw out that line now because it's at a right angle. Draw it on out. Don't worry about the length of it for the moment. Okay, and we're going to do the same the other side. Line it up and draw it on out. So those lines are at a right angle there, yeah? Lovely. Now, what I want to do now is I want to draw what's called the ground line. So the ground line can be positioned anywhere after the far edge of the plan view. And the ground line is like your XY line, okay? So it's that point that's on the ground. Now, what we want to do there is we want to use our sliding set square. Make sure that we're all good here. Level, same angle as the picture plane. Take that, and I'm just going to slide it past, a couple of millimeters past the back of the actual so I've drawn that line in there now. It's parallel to the picture plane. It's a couple of mil past the end of the plan view, and that is our ground line, and I'm just going to call that GL, ground line. Okay, now there was one other bit of information given to us. We were told that the horizon line is 50 mil above ground line. So what you can do here is mark up 50 millimeters. There's 50 there. Okay, and what we can do is, again, using the sliding set square, line up with your ground line. Okay, and draw in your horizon line. Okay, so that's horizon line. HL. Okay, now that horizon line contains vanishing point 1, VP1. Okay, so I now have my picture plane, my ground line, and my horizon line, and what I want to do is I want to actually form the view of the object up here. Okay, so just before we do I suppose of the measured bits and pieces, what we want to do is we want to locate all of the points on this plan view on the picture plane. Okay, and how do we do that? Well, We can label them, but what I will say is each of the points here in the plan view has to be joined back to the spectator. Okay? So imagine that this is the object and each point travels back to the eyes of the spectator. Okay? So we're going to draw them back like so. Okay? And likewise over here. And the back corner here as well. Okay. Now, where each of those lines crosses the picture plane, alright, this is, they are the points, alright, we'll call that, we'll say that's 1, 2, 3, 4, 5, 6. Okay, I just want to put in a little right angle symbol there, just to indicate that the bisector line initially is the picture plane's at a right angle to it. Okay, now so we have these points where they cross the picture plane, and we're going to project them out now at the same angle as the vanishing lines going out. So these vanishing lines on the side. So what we can do is we can set up our sliding set squares here. Okay, and we can project out those lines, and then we can start to work with the views. Okay, so I'll just make sure that your lines are good and accurate. Just making sure here, especially when you have a long run, for lines to be drawn. Okay, so there we go there. I'm going to draw that one out now, and I'll draw each of these out with a blue line. I'll just draw them on out, don't worry about the length of them. Okay, we can just draw them on out for the moment. Sorry there now, my pen is a little wasted there. Go on to the next one. 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 Okay. So I have those lines drawn out there, and of course you'll be drawing them with a pencil more likely. Only with my visualizer here, the pencil, it just doesn't show up well enough. So I've extended out those lines, okay? They're parallel to the vanishing lines travelling out, okay? And obviously at a right angle to the ground line and the vanishing line, or the horizon line here. What I'm going to do now is I want to focus in on a particular line that I have left. That's the line for point A, okay? And I'm going to focus in on this now, and I'm going to draw that with a different colour. I'm going to draw that on out with pink, so that we can kind of have a look at this line and see how we're going to use it. So, that line coming from A, okay? This line is crucial, because any point that's contained on the picture plane, it can be referenced as a true height. As true height meaning you can take the actual measurement from the question that's given and apply it. So point A, that front corner, on the question I gave, the height for point A from the ground up is 30 millimeters. So what I'm going to do is I'm going to mark out from the ground line, out on that line, 30 millimeters. Okay? So from here out, 30 millimeters. Like so. Okay? Now what I'm going to do is I am going to connect the top and bottom of that line now that I've marked to the VP1 and VP2. That's VP2 there. Okay? So I'll just draw it back to VP2. Okay, draw this one back to VP2. Draw this one back to VP1. And that one back to VP1. Okay, like so. Now they are vanishing lines, okay, or perspective lines. Now, what I'm going to do is I'm going to heavy that little bit of a line that represents the front corner of the object, because we're going to build it out from here, okay? So, the vanishing lines going this way. We'll focus on this side, and this will be the side with the L, okay? Okay. So, if we want to define the length of the line going back this way, what we have to do is we go, right, well, if that's A, and it travels back, okay? Well, here's A in the plan view, and it travels there, doesn't it? So what we do is we track this point that we drew back to the spectator. Where it passes the picture plane, we extend out, as we have, and that's where it hits, doesn't it? right there. So that point there now defines the length of that side of the L block in the actual perspective elevation. Okay, and you can see it's much shorter than the actual real one. Okay, and that's all to do with the position of the spectator in relation to the object, the angle they are at, how far away they are, and so on. Now, the height at the back here of the L block is 60. Now, because this point is not on the picture plane, we can't just mark up 60 millimeters there. But what we can do, we can imagine this L block was like a cube, and that on top of the 30 that we've marked, we can mark another 30, which brings us up to 60. So that's what I'm going to do now. I'm going to mark up that extra 30 on that line coming from A. And what I'm going to do is I'm going to draw it back to the VP1 and to the VP2. Like so. Now I can go, right, that back corner point now goes up to this top point here. Alright, because that's defining the height at the top of it now, as it vanishes back. Like so. So now I have the back edge of this cube. Alright, and you should begin to see it forming now. Now, I'll follow this point. Let's say I want to join the line from here to here. Okay, and if we follow that line back to S, it crosses the picture plane here, out it goes. So that means that's it there. Okay, and likewise then where it crosses the line here, that'll be another one here. Okay, so what I can do now is I can heavy in that bit. I can heavy in this bit here. And I can heavy in this bit right here. That's the side done, the L side that's facing us. Now we'll work on this front facing part, if we want to call it. So again, we look to how long will this line be across the bottom of the front. But here it is in plan in the elevation up here, the perspective elevation. What we have is that line brought back, crosses the picture plane, we projected it out, that means it's there. We'll look above to the next line, that means it's there. Okay, so we can heavy in that little front section like so. Alright, so that's the front. Now we'll go, well, how do we find the line going back? From that point now, I can take a line, vanishing line, back to VP1. Okay, and where that line intersects this line, this point here that was brought back to S, there it is there on the picture plane, follow it out, there's the intersection point right there. Okay, so I can actually draw that bit now heavy. Okay, and finally then I can join from there to there. And I have just one more surface to complete my view. I'm going to take this point and I'm going to vanish it over to VP2. Okay, and directly above this point we'll mark where that line intersects. And we'll be able to join it like so. And then what I end up getting is the actual finished product. Okay? So, that now, let's add a little bit of colour there. That is your perspective elevation. Quite simple, real nice. Okay, and go for a little bit of orange here. Alright, and it's a really visual topic, but one that is very intuitive. And when I mean intuitive is you're kind of going point to point all the time. Maybe it's a little harder to visualize, maybe it's not, you know, depends. But you can certainly see that as you go along you're picking up the next point all the time, and be able to then generate your full view. Okay, so this we would call our perspective elevation. Okay, and that's it, complete there. Okay, thanks very much guys. Okay, hope you enjoyed it.